Hello, this video is about trigonometry, section 2.1. Trigonometry is a very different kind of math subject where it's this big pile of information. So in an algebra class, your information is kind of sequential, like chapter 1 leads into chapter 2. You have to master chapter 2 to really understand chapter 3. Trigonometry, there's this whole pile, and you can kind of jump in any area, and then you just kind of keep building on that information. So whenever you're starting trigonometry, it's going to seem like just a completely foreign language and you don't understand anything at all. So just kind of keep going, keep taking it little piece at a time, try to, just figure out the answer to this problem and try to keep moving to the next one. And the more you've progressed and the more information you get, it all connects back and it all starts to make a little bit more sense. So you really just have to kind of keep going with this trigonometry. You can't try to depend on, something that you've learned in another class as much as this one. You have to, take the next chapter and try to use what you learned in the last chapter to fill in the gaps. So once you get past chapter 1 is not gone. Chapter 1 is now in the pile of chapter 2, and it all goes together. So just kind of keep that in mind, how it's very different than most of the classes like that. So we're going to start out, with some information that you've probably heard before in like geometry class and things like that. We do use some Greek letters, so I just kind of put a little reference up here. So if I said beta, I'm talking about this guy right here. So it kind of looks like a B with a long end there on the left. So we'll use a lot of these here and there in the classes. Theta, this one with a 0 with a slash through it, comes up a lot. We're obviously going to be talking about angles and circles and things like that. So just keep in mind when we measure an angle, we start from the initial side at degree 0, and we'll talk more about that. And then we move counterclockwise to the terminal side, like this right here, always counterclockwise. We look at different kinds of degrees. We classify them as acute or obtuse. And you probably heard these before. Acute, you think acute little angle is any angle less than 90. And then obtuse would be an angle that's bigger than 90, but still less than 180. Actually, no, I think it would still be obtuse over 180, but for the most part, we're only going to see obtuse angles up to 180. And then once they go past that, we kind of get into a whole different world of things. But for the most part, those are the starting classifications. So if I were looking at this degree right here, 130 degrees, he would be one of those obtuse angles. He is larger than 90. But then, of course, 15 is smaller than 90, so he would be an acute angle. So it also asks us to find the complement and supplement of these two angles. So complement would be the angle that makes it add up to 90, and then supplement would be the angle that makes it add up to 180. Now remember, 180, if you think about, if you jump up in the air and turn an about face, that's a 180 because it's complete opposite direction. It forms a straight line when the two are connected. And then the complementary angles make that perfect right degree angle there, that perfect corner. So just kind of a silly thing to help me remember the difference between these two. I think a C, if I can draw it there. There we go. Looks kind of like a right angle right there. And then see if I can do it. A supplementary has two right angles. Kind of looks like the letter S there. So just a silly thing to help you remember. So if I wanted to know the complement of a 130 degree angle, that's a little bit sneaky because it has to add up to 90 specifically. You might say, well, it's bigger than 90. Let's start with this one. This one's complement would be 75 because 90 would be 15 and 75. 15 and 75 would combine to make a 90 degree angle. So 90 minus 1 equals the other. So I have to do that same pattern. If I do 90 minus 130, we're going to get a negative, but that's okay. Keep your calculator handy on these. So I can't think of that one off the top of my head, but it would be negative 40 degrees. And that's okay. The complement is negative 40 degrees. So next, the supplement the one that makes it add up to 180, does an about face straight line, is 180 degrees. So we would say, what is 180 minus that angle? 130. In this case, that would be a 50-degree supplement. And this one, 180 minus that small little 15-degree angle would equal 165. So the supplement would be 165 degrees. You would need that much more to make it into a straight line. So just kind of some terminology there. So next, if we wanted to try to kind of feel our way through some of these problems, we say this problem, how many degrees would the hour hand move in 8 hours? Well, like I said, 180 is a complete about face, a straight line turnaround. Well, a 360, if you watch any X Games or anything, you know that's completely all the way around. So to go from 12 o'clock all the way around to 12 o'clock again would be 360 degrees. And that, of course, was 12 hours. So we have to try to think of it as a part. So 8 hours was the part of the whole 12-hour about face. So in that about face, we went a full 360 degrees. So we wanted to know what is 8/12 of the full 360 degree turn. And we can plug that in just like that. And that would give us 240 degrees. So no matter where you started, if it was at noon or 2 or 3, if you went 8 hours later, that angle would be 240 degrees. Okay, so in the past, you probably learned that the interior angles of a triangle add up to 180 degrees. So no matter what your triangle looks like, if it's a perfect equilateral triangle, if it's an isosceles, if it's just a crazy triangle like this, if it's an obtuse or acute triangle, no matter what, if you cut out those 3 interior angles and add them together, they always add up to 180. So that's for any triangle. So I could look at just this lower triangle, I could look at just the upper triangle, or I could look at this bigger triangle here, where I have this, this, and this. So knowing that I have that option and that they're always going to add up to 180 degrees, I can find mysterious angles like X, Y, and Z. So first off, I noticed that in my lower triangle, looking at this guy here, I have the most information. This one's 33, 133, and then of course the mystery X. So if I know that those 3 add up to 180, I can take the pieces apart. Say, okay, well 180 minus the 2 that I know should leave me the one that I don't know. And that's going to give me 14 degrees. So now I have found that X is 14, and that's going to help me find some more. Okay, now X is part of this angle XY, but I don't really know which part. So I don't know that X and Y are exactly the same. That's a common mistake I see a lot. They say, well, if X is 14, then Y is 14. But you don't know that. Y might be bigger or smaller. But I do know that this right here is a straight line connecting these 2 triangles. And I know that a straight line, just like we talked about, is 180 degrees. So if this part of the straight line was 133, then Z must be the supplementary angle. So 180 straight line minus the 130 degrees, 33 degrees, sorry, that was over here, would equal the other supplementary angle of, turn my face, 47 degrees. So that would equal angle Z. And now that I know angle Z, I can look at this upper triangle right here and use these 3 interior angles adding up to 180 to find Y. And then we could see maybe X and Y do match, but we're not sure yet. So then 180 minus the 114 from this angle here minus the Z that I just found of 47 degrees would equal that last missing angle of Y, which would be 19 degrees. So he actually was not exactly the same. He was just a little bit bigger. That's why you got to be careful making those assumptions. Also, a lot of times you'll find that they draw this the triangles not to scale on purpose. So they'll make it look like X was bigger than Z or something like that. But when you really run the numbers, that's what matters. So they'll purposely try to throw you off with the picture. So just be careful. Next over here, we've got this circle, but don't be intimidated. We got this. Just remember that the way to make a circle is to take something from the center and go equidistant all the way around. So that means that this distance right here from the center to the end is exactly equal to this distance here from the center to the end. And they labeled them both the matching distance r. So it also tells me that AB from here to here is equal to 1 and AD is equal to 3. And it says with that information I can find r. And it may not seem like enough, but this is a right triangle. So remember that Pythagorean Theorem says that a squared plus b squared equals c squared for any right triangle. And the right triangle always has the c as the hypotenuse, the one across from the right angle. So it still seems like we don't have enough information, but let's start putting our pieces together. So here's one of the two shorter sides is of course 3. So 3 squared plus, here's the other shorter side is r squared. And here's the sneaky part, the hypotenuse is 1 and r. So think about if you knew what r was, so just pretend it was 7. Okay, obviously not, but just for pretend. Well, if this was 1 and this was 7, 1 and 7 would make 8. I would add the two numbers together. So once I know what r is, it is r and 1 more. So that means I need to take 1 plus r and square it. Now what's sneaky is without knowing r, I'm going to have to FOIL this because the order of operations say to add before we do exponents. It would tell me to do the grouping inside of the parentheses before the exponent. So over here, this is pretty easy. 3 squared is 9, sorry, not 9 squared. And then r squared is just r squared. But over here, we have to make sure that we FOIL this out. 1 plus r and another 1 plus r. So that's going to give me 1 plus r plus r plus r squared. So I want to try to solve this. I'm going to try to get everything together. I'm going to get all of my r's on one side together. So if I minus this r squared to bring him over here to get my information together, and that works nicely because those completely cancel. The r squares cancel on both sides. So that just leaves me with 1 plus r would be 2r. And now I can just solve this for the mystery letter r by algebraically isolating that. If 8 equals 2r, divide by 2, 4 is equal to r. And again, you can kind of see it doesn't seem like that would be to scale. If this was 1, that looked like it was shorter than 1. They did that on purpose to try to trick you. I could check my answer by doing 3 squared plus 4 squared and make sure that that was equal to 1 plus 4, 5 squared. And that would work out. And be 9 and 16, which equals 25, which is the square of 5. So just be careful. They try to throw you off with that scale. Next, we've got the airplane here. Now we always have to draw it out. Okay, it's too much to try to think of just in your head. So here's my super awesome drawing of an airplane. He is flying at an altitude of 1584. So that means that's straight down from the airplane. And if you've seen any of my other videos, you know I'm terrible at drawing straight lines. There we go. Okay. And then assuming that this is, Earth, we're going to assume this is pretty much a right angle to the ground going straight down. So this distance was the 1584. Okay. And then it says the horizontal distance from the plane to the runway. Okay, so here's this little airport he's going to over here. Was 0.4 miles. Then what is the diagonal distance from the plane to the runway? See if I can do better. A little better. Okay, so this is the one we want to know. Now, what we have to be careful of is obviously these two numbers are quite different. This one is feet, while this one is miles. So it's really the same problem as what we just did. We've got this right triangle. We're going to use the Pythagorean theorem, but they tricked us by giving us two different units. Now, it did remind us here that 5,280 feet are in 1 mile. So I could switch this miles to feet. I could switch this feet to miles, but let's see what they want in the end. So it says use the Pythagorean theorem. They gave us a hint to find the diagonal distance in miles. So since my final answer is going to be in miles, it would be a little bit harder to change this to feet, get an answer, and change the answer back into miles than it would be just to change this into miles from the beginning. So I'm going to take my 1584 and see what would that feet distance be in miles. Now remember, when you're switching, you want to cancel the unit that you don't want, and I want to put the unit I do want on the top. So 1 mile is equal to 5,280 feet. So I know that this needs to divide. Also, it should make sense. If you accidentally multiplied, you'd get a huge number of miles, and you know that this many feet would not be lots and lots of miles. So to stop and make sure it makes sense, this gives me 0.3 miles. So that seems like an appropriate value considering the other number they gave me was 0.4 miles. Now I'm going to use my Pythagorean theorem. 0.3 was a shorter side. 0.4 was a shorter side. And remember, be careful right here that it's going to give me not just x, but x squared. So if I type that into my calculator, I get 0.9 and 0.16, which is going to give me 0.25. Nope, I said that wrong, sorry. 0.09 and 0.16, which is going to give me 0.25. And then the square root of 0.25 is 0.5. So his diagonal distance to the runway is half of a mile. So like I said, if you went the other way, if you changed this into feet, you'd come out to the same answer, except you would have gotten your answer in feet, and then you would have had to do another conversion to change those feet back into miles. So doing it this way is just a little tiny bit shorter. Okay. All right, so there are two special triangles that appear a lot, the 30, 60, 90 and the 45, 45, 90. So because they appear so much, somebody went and kind of found this general pattern so they didn't have to keep doing the Pythagorean theorem every single time. So I said, since this is an isosceles triangle, the matching angles mean the sides would also match. This side would always match this side. And if you do your Pythagorean theorem, it always ended up being the distance of the shorter side times the square root of 2. In a 30, 60, 90 triangle, they found this pattern. They said if you named the shortest side across from the 30-degree angle x, just in the generic variable x, so if you was a 5, then the hypotenuse would always be double that. So if this was a 5, this would be a 10. And then the second longest side, the medium side, would always be the shortest side times the square root of 3. So it's just this kind of shortcut that they found for using a little bit less information on these specific triangles. So let's give it a try. This one, they shoot a cannonball into the air. So here's the cannon here. And then it goes up at a 45-degree angle. And it says that we're going to ignore gravity and everything. And then we want to find, so notice mine is not exactly to scale. We want to find how far it travels before he is 1,200 feet off the ground. Now be careful. How far did it travel? Is that this distance or this distance? Is that going to be x or y? So it didn't necessarily say, so it didn't say like parallel to the ground or anything like that. It was the actual literal ball. So how far did the ball move from the cannon to this point where he's 1,200 feet in the air? Now, if it did say along the ground, that would have been the easiest answer. X would have been exactly the same since this is a isosceles triangle. So X would have been an easy answer of 1200. But Y right here, this hypotenuse, is going to be that value times the square root of 2. So actually we're pretty much done. It's just going to be 1200 square root of 2. Now if I did want that as a decimal value, because we are thinking in, actual feet and miles and stuff, so there's more context, I could punch that into the calculator to see that that is 1697.056. Just to make sure that it makes sense, because I know that this side would be literally longer than these two shorter sides. And sure enough, that distance is longer. Next, I've got the escalator at the mall here, okay? And it says that the escalator is carrying people a vertical distance of 16 feet, okay? It also tells us that it makes a 30-degree angle with the ground. Just be careful of the wording there. So the ground and the escalator make a 30-degree angle. Okay, and that's all they told us. So it doesn't seem like there's enough, but since it's the special 30, 60, 90, I know more than I think. So I assume if it's built up to code that this is a 90-degree angle right here. I hope it's not a slanty escalator there, which means that since these always add up to 180, 30 and 90 and 60 add up to 180. So even though they only told us the 30, I know that this is a 30, 60, 90. Okay, so that means the 16 is the shortest side. He would be like X. Okay. Now, if they wanted to know the distance with the ground along the floor here, that would have been X square root of 3. So that would have been, let me label these here, Y and Z. So then Y would have been equal to 16 square root of 3. But they asked how long is the escalator, meaning the actual stairs themselves, moving from the ground up the side. So that would be Z, which is just double of X. And 2 times 16 is 32. And that is, of course, in feet. Okay, forget to put this one was also in feet. All right, last one at 45, 45, 90 again. But this time they tried to make things sneaky because they gave us the longest side. Okay, so if they said the longest side was equal to 4, we're used to getting the shorter side and just matching it up with the X. But don't worry, we've still got this, because we just know that now 4 is comparable to our X square root of 2. So if I needed to know the X, I would just divide both sides by the square root of 2. And then I can punch that in my calculator. Just be careful to get all those symbols in there right. And I should get that X would be 2.8284, which seems right because I do expect it to be something smaller than 4. So you can just make sure in context that it seems right. They're not crazy small. If I got like 0.7, I'd be a little suspicious. If I got anything bigger than 4, I'd be suspicious. So just make sure in these word problems that your answers make sense. They seem about right. So 32 was a reasonable distance. It wasn't like, 8,600 or something. So just keep in mind, like I said, that all of this is going to mush together. So as we get deeper into this, it's going to seem overwhelming at first, but we're putting all these little pieces together and it's going to make one big, beautiful picture.